Okay, folks, so welcome back. And in this video, we're going to focus on another functional group. Yeah. I told you again and again and again. This is going to be loaded with nomenclature rules, and we're going to have to get used to them. So with an amide, we have to start with the functional group for an amide. What is it? What does it do? So an amide is a carbon with a double bond and a NH2 or a nitrogen-containing compound that's there on the right-hand side. We are going to see NH2 there most of the time, but this is our template that we will be using for an amide functional group. Again, it does not have to be NH2. We can probably see structures that are going to be NH with an R group and an NR2 group. They could be the same group, they could be different groups, but we will treat those just like we treated amines back in Chemistry 251. So that's probably the first that I would look. If you did not have me for Chemistry 251, that's okay. If you did have me for Chemistry 251, both sets of people probably need to go back and do a quick review when it concerned the amine nomenclature system. All right, so we're going to touch on it here. I mean, that's my job, right? Is to teach you how to name an amide. I'm not just going to tell you to go read the textbook. I mean, that's what I get paid to do, and that's what I'm going to try to do here in the next 20 or 30 minutes, depending on how long this video is going to be. So sit back and hope you learn something in the next few minutes at least before you start to tune me out and start to ignore me and maybe start to get distracted and go and check email and go on Facebook or TikTok or whatever kind of social media platform that you are with me jibber jabbering in the background. Yeah, I know. That's how things go, and I'm okay with that. All right, so now let's talk about an amide. How do we name an amide? Let me show you how easy this is going to be. A carbon double bond O with an NH2, and let's say over here on the left-hand side, we have a CH3. How do we name it? Okay, well, let's think about Iupac. Iupac is so concerned with finding the longest carbon chain. Okay, so how do we find the longest carbon chain? You just circle it. Okay, there's the first carbon, there's the second carbon. Carbon 1 and carbon 2. What do they call a two-carbon chain? Oh, well, Tracy, you've taught us very well because this is an ethane. Okay, well, good. That's an ethane. So what do you think we're going to do with the ethane? We drop the E just like we've always have in all of the carbonyl and most of the Iupac nomenclature that we've had at this point. So when we drop the E, what on earth do we add on to the end of the name? What kind of functional group is this? Oh, well, that's an amide. Okay, well, that's the ending that we'll use. Ethanamide. That is the name for this structure, folks. It doesn't get simpler than that. What is the longest carbon chain? Name it, drop the E, and add the word amide onto the end. And that is the Iupac, accepted Iupac name for that structure. Okay, so let's do another one. Let's do C double bond O with an NH2, and over here, let's do a CH2, a CH2, a CH2, and maybe a Cl. How does that change anything? It doesn't. It doesn't change one darn thing from what you've learned in 251 and 252. So what does Iupac say? What's the longest carbon chain? Okay, so the longest carbon chain is a 1 and a 2 and a 3 and a 4. Okay, so that is a butane. But drop the E, and what ending are you going to add? Amide. Okay, well, there you go. Butenamide. That is the name of this structure, butenamide. However, there's something that's lingering, and what is lingering is this chlorine here at the very end. So I'm going to have to go through and I'm going to have to name that chloro group. How do you think we're going to do that in Iupac? Well, in Iupac, the Cl was a chloro. Okay, well, there's halfway there. And what else are we missing? Well, we normally gave it a number. Okay, well, we do the same thing here. If this is carbon 1 and carbon 2 and carbon 3 and carbon 4, that means that this is a 4-chlorobutenamide. Folks, I've told you over and over, this is a buildup process. What we have learned very early stages in Iupac does not go away. We are playing the same game. Sometimes, though, there's just different rules that we're going to have to follow, and one of those is what kind of ending do we give these molecules when we name them based on the functional groups. But pretty much everything stays the same. Longest carbon chain, give it the name the substituents, give them the numbers, and then away we go. All right, so here's another example. This is an amide, but it has a benzene on it. Okay, so this ring structure is attached to the carbonyl. And we always said that when we have ring structures, we kind of handle these a little differently. We name the full ring. Okay, well, what is that ring called? Well, just like we've seen before in the past with some of our other examples, that is a benzene. So we write out the word benzene. That's what we've done all along, and we're not going to change the rule now. Why would we do that? So we will write benzene down. Now I have to bring in this amide group. Well, remember the C double bond O is going to be a carbonyl. So this is a carbo unit because it's a carbonyl. And then we add the word amide onto the end. All right? Okay, so now that we've done that, let's say it. Benzene carboamide. Okay, well, we're close. We're close, but something weird happens here. And what happens here is that we typically add an extra letter of an X. And we call this carboxamide. Oh, okay. So that rolls a little bit better off the tongue. It looks a little bit better on a sheet of paper. It makes it easier to say benzene carboxamide versus benzene carboamide. That's kind of silly when you say it a little slower, right? So carboxamide, it sounds like it goes together. So that's why we add that extra little X in there. You've seen us kind of add a letter here and there. And if you're close, folks, I'm going to give you credit. Okay, like I've always said before, I'll give you credit for those close answers. If things aren't in alphabetical order, I typically give you credit for it. If things are not written in the proper way and you've left out a letter here and there, if the majority of it is correct, I give you the benefit of the doubt and I give you the points. Blackboard, not so nice. Me, on a test, on one of my 20-page tests, well, I give you the benefit of the doubt, right? All right, so let's do one more, and I'll just do this one up here on the upper right-hand side. We'll do a ring structure, so there's the ring, and then off of one of these, I'll do a carbon double bond O with an NH2, and off the other one, I'll do a CH2 and a CH3. So we're going to have to name this as well, all right, and we're going to use the Iupac rules for this. Okay, well, no big deal. That's what we've been doing. So it's just a ring system. That's it. But I'm going to have quite a bit of room here because we're going to have to name the entire ring. Just like we did with benzene, we've got to name this ring too. So this ring is a cyclohexane. So as before, I name the entire ring. And then I have to bring in the carbo unit. So this is a carboxamide. So that takes care of this piece, and that takes care of the ring, and this is carbon number 1 right there. So I'm going to have to go through, and I'm going to have to name the substituent, right? We've got something hanging out, and we have not taken care of that yet, and that's this CH2CH3. Well, I know that that's called an ethyl group. Okay, well, that's great. Good for you. There's ethyl. Ethyl cyclohexane carboxamide. However, I'm missing a number. Where is that ethyl attached? And that ethyl is attached to carbon number 2. So 2-ethyl cyclohexane carboxamide is going to be the accepted Iupac name for that structure. All right, so that's great. Those are Iupac names. That's how we do those. Find the longest carbon chain. Give me the parent name. Drop the E. Add amide. Put your substituents on it and put your numbers on it. Nothing has changed except for the ending. Now, let's go through and do a common name for each one. Oh gosh, another functional group, another 2 sets. I know, that's the way it is though. So just bear with it. We'll get through it together, and then off to the races we can go for the reactions. So if I start off with the very first one that we did, ethenamide or ethanamide, how do we common name it? Okay, well, what's the common name for 2-carbon chain? Well, we've used it over and over. It's acete. Okay, there's no difference here. It's still acete. We're using the same rules. We just changed the ending. What functional group is it? It's an amide. Okay, well, here we'll add the word amide all over again, and we call this acetamide. That is the structure for acetamide, and that's what that means. Acete is 2 carbons, and amide is a C double bond O NH2 functional group. There you go, folks. That's all there is to common names. Now let's go to our next one. 4-chlorobutenamide. Use the common nomenclature system that we've always been using. Okay, well, what does that mean? Well, it looks like there's 4 carbons in a row. 1, 2, 3, 4. So the word for a 4-carbon chain in common nomenclature language is butyr. Okay, well, we add amide onto the end. A-M-I-D-E. And we know there's a chloro on it. That hasn't went away. It's still a chloro in the beginning. But common names do not use numbers. So I can't use a 4. And as with all the other common nomenclature system in the carbonyl world, we do not give this carbon of the carbonyl the alpha. We start next to it. So there's the alpha, there's the beta, and there's the gamma. So on the gamma carbon, we have a chloro. So gamma chlorobutyramide. That is going to be the name, the common name of that structure. Next one, the benzene with the amide functional group. Well, these are always kind of weird because it's a benzene-related compound. And this is going to be called a benzamide. They shorten that much, much better. And again, all of these common names are used more often in a laboratory. Don't ask me why. They just do it. It's been around for years. That's what we ask. That's what we do. That's what we say. That's what we order. And again, it drives Iupac crazy. The one up in the top right-hand corner, folks, that does not have a common name. I cannot give that a common name. And I'll try to be good to you on this upcoming test with the carbonyls, because if it does have a common name, I will tell you, give me the common name. So that way you know what to expect, or you know maybe what to come together with and kind of answer. Put the puzzle pieces together and regurgitate an answer back out and hope and cross your fingers that it's correct. But at least we'll give you an idea if it does have a common and an Iupac name both. All right, so those are the rules to name amides. Again, very similar, just a different group with a different ending. So add this to your cheat sheet chart. Add this to the chart that I keep telling you to make, and now you have a row for amide, and you have a column that says Iupac, and you now know, name the substituent like before and add the word amide. But you also now know, use the same process for the common name. So you just use the common name for the carbon chain, but you still use the ending amide onto these things. They're identical, all right? Now, what if groups are attached to the ends, the nitrogens of these amides. How do we name these? This is nothing new. We saw this back in 251 when we started talking about the amine structure group. Amines. Okay, well, here we go. Here is a carbon double bond O with an N, and let's take one of those hydrogens off. It's not an NH2, but now it's a nitrogen that has a 6-membered ring. And over on this side of the carbon, we need to finish the structure out, so we'll do a CH2 and a CH3 here. How do we name something like this? Okay, I don't want you to focus on that group attached to the nitrogen yet. We'll work with that a little bit later. I want you to give me the Iupac name for what we have here. Leave off the group that's on the end. Okay, well, that basically means a 1 and a 2 and a 3. So this is a propane. Drop the E, add amide. Propanamide. All right, well, that's good. Now, there's no other thing attached to that main chain. It's just the 3 carbons, and that's it. But now we have to bring in this cyclohexane ring. And we have to get you to understand that that cyclohexane ring is attached to the nitrogen. And back in the world of amines, when we did it a semester ago together, the way that we identified that is we put a big capital N out in front of the substituent name. So this cyclohexane is a cyclohexyl, just like an alkyl group: methyl, propyl, ethyl, butyl, pentyl, hexyl, heptyl. You get the idea. You get the drift. So the name of this compound is N-cyclohexyl propanamide. There you go. That's how we handle those. We just write an N if the group is attached to the N. Well, hopefully that makes sense. Again, it's not rocket science sometimes. I mean, these people that sit on the Iupac board, they might have PhDs, but that doesn't mean that they're smart or creative. All right, so let's look at another one. Let's look at C double bond O, and over on this side we'll have a nitrogen. But let's say that this nitrogen has a CH2 and a CH3, but it also has a CH3 that comes down this way. Oh. And then over on the right-hand side, let's do a CH2 and a CH2 and a CH and a CH3 and maybe a BR that's there. How would we name it? Oh my goodness. What does he want me to do? I'll use the basic rules. Use the basic rules that we've always talked about. Have you been paying attention? Now's the time. Okay, longest carbon chain. Longest carbon chain. 1, 2, 3, 4, and 5. So this is a pentane. Drop the E. Add a what? You have better told me an amide. Pentanamide. All right. Good enough. On this thing, on the amide, we also have 2 groups that are attached to this nitrogen. How do we handle it up above? We handle it the same way here. Well, it looks like we have an ethyl group, and it looks like we have a methyl group. Both of those are attached to the N of the nitrogen. Which one comes alphabetically first? E. All right. So I'll write that down first. I have a N ethyl, but I also have another group attached to the N. So I have to write the N again. Methyl. Folks, that is no different than groups appearing on the same carbon. If I had 2 methyl groups on the carbon, I would write 2, 2. every group needs a number or an identifier. This is no different. The ethyl needed the N in front. The methyl needed an N in front. That way I can convey to you in a name that this ethyl is attached to the nitrogen of the amide. This methyl is attached to the nitrogen of the amide. That has to be clear cut. And that's the way that we ensure that it is. But yet I'm not finished. Because now I have this bromo group. I've got to figure out a way to convey to you where that bromo group is. And it looks like this is on carbon number 1, 2, 3, 4. So on carbon 4, I have a bromo. 4 bromo, N ethyl, N methyl, pentenamide. All right, let's do one more. Carbon double bond O, a nitrogen with a CH2 and a CH3 and a CH2 and a CH3. And then over on this side, we'll do a CH2, a CH2, and a CH3. There you go. Do-si-do. With your partner, go. All right, so we need to come up with an Iupac name. Same rules exist. Longest carbon chain, blah, 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 blah. All right, 1, 2, 3, and 4. All right, so this is a butane. Drop the E, add the amide. There you go. Butenamide. However, this nitrogen has 2 of the same groups, but we still treat it the same way. I still have to give a number or an identifier to every group. Well, that group is an ethyl group. There's 2 ethyl groups, right? So just as before, there's 2 of the same group, so I'll put diethyl. I don't want to write ethyl. That's silly. Ethyl butenamide. No, we can just do diethyl. It saves me some effort, saves me some time. However, each one of those ethyls are attached to the nitrogen, and I have to make that clear. So even though I can put diethyl here, I still have to put N. The first N represents the first ethyl. The second N represents the second ethyl. They still need an identifier. Again, the same thing would have happened if it was 2 ethyls on the same carbon and you tried to name it prior. Right? You would name the long carbon chain, and then you would go through and you would write 4,4-diethyl. Or whatever the case was. The same thing happens here. There's no difference in this. I am not pulling any new tricks out of my sleeve except for the way that we end the names. That's the only difference. All right, so these are ways that we handle the amide functional group that has groups attached to the nitrogen. Notice that every single one of these I only gave you one name. That one name was all Iupac all the way across the board. There is no common names for any of these that are very easy that I want to talk about. So these are examples of where I would tell you on a test or on an assignment, give me the systematic name or give me the Iupac name for these structures. If I want common, I'll say common. But remember, Iupac and systematic are referring to the same thing. All right, so that's where this video is going to stop. And in the next video, we will talk about this idea that nitrogens can also make a ring, just like esters did. So if I have an amide group with a nitrogen, nitrogen is very comfortable in a ring as well. So we're going to have to learn how to deal with these, how to name these, the proper process to go through. It's very similar to the lactone world. Very, very similar. We also call them something very similar, and we're going to call these lactams. And you can see why we end it in an AM, because AM are the first 2 letters of amine. So lactams are amine-based rings, and lactones with the O for the oxygen are the oxygen-based rings, which come from the esters, all right? So that's a very quick way to figure out which one is which, because some people do have problems trying to distinguish between the both of them, all right? So lactam, AM, amine, and it's that C double bond O-N that is involved in the ring. So we're going to have to learn how to name these before we learn how to do reactions with them. All right? So in the next video, that's where we'll pick up. And we almost are finished with nomenclature.